Hello students, welcome to the third lecture of decimals and fraction. Okay, so before going forward to the new content of this lecture, let's recap a few things from previous lectures. So in the previous lecture, what we learned was the types of fractions. Okay, what are proper fractions, improper fractions, what are mixed numbers, what are equivalent fractions, like fraction, unlike fraction, and their difference. Okay, and we also learned that what are proper equivalent fractions, improper equivalent fractions, and the difference between these two. Okay, so again we also learned that what are the types of decimals. Okay, so we learned that there are basically two types of decimals. One are terminating decimals and one are non-terminating decimals. The decimals in which we have finite number of terms after the decimal point, that is let's say for example 2 3 7 8. Okay, so the number of digits after the decimal point are finite, like here is 1 2 3 4, only 4 digits are there, nothing much. Okay, so these kind of decimals were terminating decimals, and for non-terminating decimals we got that like 0.2222 or equal to 0.2. Okay, these are non-terminating decimals. That is, here the 2 is not stopping. Okay, and that is after 0.2222 and so on. Okay, there is no stoppage for 2. Okay, and we denoted it by 0.2 bar. Okay, we denoted the bar symbol after the number of digits that are reappearing. Okay, like for 0.678 678 678 and so on, we will write that 0.678 bar. Okay, because 678 is the repeating pattern here. Okay, and again on non-terminating decimals, what we learned was it was further divided into two categories, that is non-terminating repeating decimals and non-terminating non-repeating decimals. For the second category, that is non-terminating non-repeating decimals, we got the example of pi and e there. Okay, these are irrational numbers. This is also called as irrational numbers. Okay, and this for this non-terminating repeating decimals, we can see that this example is appropriate. Okay, so let's go forward to the content of this lecture. Okay, so in this lecture we will be doing some exercises on decimals and fractions. So what does problem 1 tells us? Problem 1 tells us that we need to find the result of 3 by 4 plus 1 by 2. Okay, so let's see what 3 by 4 plus 1 by 2 is. So we need to calculate 3 by 4 plus 1 by 2. Okay, so in order to get its answer, what we need to do is we need to compare the two denominators. Here one denominator is 4, one is 2. Okay, so what we need to compare here? So what we need to do is we need to first find the LCM of 4 and 2. What is LCM? For L it is lowest, for C it is common, for M it is multiple of 4 and 2. So we already know the steps. That first step, what we need to do, we need to find the multiples of 4 and 2. So multiples of 4 is 4 into 1, 4 into 2, 4 into 3, 4 into 4, and so on. And multiples of 2, 2 into 1, 2 into 2, 2 into 3, 2 into 4, and so on. What this is equal to is, this is actually equal to 4, 8, 12, 16, so on. And this is equal to 2, 4, 6, 8, 10, and so on. Okay, so here you can see the series. Okay, so lowest common multiple, we found all the multiples. Okay, then we need to see what are common between these two series. So between these two, what we can see is 8 is common, right? We can see here that 8 is common and 4 is common. Okay, So since 4 and 8 both are common, what we need to do is we find the lowest. What is the lowest? Between these two, 4 is lowest. Between 8 and 4, 4 is the lowest. So what will be its LCM? It will be equal to 4. Okay. So now we find out 4. So here what we need to do is we need to make the fraction with denominator 4. Okay. So 3 by 4 need not be converted. Okay. So 3 by 4 remains as it is. So what we need to do is we need to convert 1 by 2. So how we can convert 1 by 2 into a fraction with denominator 4? So let's see. Let's write 4 in the denominator first. So if I multiply 2 down here, it will become 4. Okay. So it becomes 4. And since we have multiplied 2 down here, okay, we need to multiply 2 down there. Okay. So 1 into 2. Okay. So we have now then the denominators same. Okay. 4 and 4. So now we can add it as denominator is same. So 4 is in the denominator, then 3 plus 2. So what we got is 5 by 4. So 5 by 4 is the answer here. Okay. So we found the lowest common multiple. First we found out the multiple, then we found out the common part. Okay. Then we find out what is the lowest part. Okay, lowest between the two series. And we found out that 4 is the LCM of 4 and 2. And then what we did was we converted each fraction to have a denominator of 4. Okay, what we did was we multiplied in the second fraction the numerator by 2 and the denominator by 2. So we got the denominator 4, and then the new converted fraction became 2 by 4. Okay, so this is how we did it. Okay, so then we added the two fractions by adding the numerators, since the denominators were same. Okay, the denominators are same, that's why you can directly add the two numerators. So then what we did was we simplified the result, that is 5 by 4. That can also be simplified to 1 by 4. Okay, mixed number. Since 1 by 4 is equal to, so it is 4 into 1 plus 1 by 4, that is equal to 5 by 4. So these two are equivalent. Okay, so let's see problem number 2. What is the result of 1 by 3 minus 4 by 5? Okay, so what we have here is we have 1 by 3 and 4 by 5. So again what we need to do is we need to compare the two denominators, that is 3 and 5. And what we need to do is we need to get the LCM of 3 and 5. So for 3 we got the multiples as 3, 6, 9, 12, 15 and so on. And for 5 what we got was 5, 10, 15, 20 and so on. Okay, so we need to find the commons. Then we found out the multiple, then we need to find out the common, that is 15 down here, you can see it. Okay, not 10, it is 15 down here. Okay, and this is the lowest, since there is no lower value here that is common, so we also found out the lowest. So LCM of 3 and 5 is nothing but 15. Okay, we found the LCM. So what we need to do is we need to convert these fractions with denominator 15. Okay, how we can make this 15, 3 into 5, and then we multiply the numerator by the same, that is by 5. Okay, so for the second fraction what we do is, here we have in the denominator 5, so how can we make it 15? By multiplying it by 3. Okay, so in order to equalize the fraction, what we need to do is we need to multiply by the same number to the numerator, that is by 3. Okay, what we had was, it was 4. Okay, so what we have right now is 5 by 15 minus 12 by 15. Okay, so what it gives us is minus 7 by 15. Okay, this is the answer. Let's see. Okay, what we did was we found out the multiple series, then we found out the common, and then we got the lowest among them. And 15 was the LCM of two fraction, denominator 3 and 5. Okay, so then we converted the both the fractions to have a common denominator of 15. Okay, this is how we did it. Okay, so yeah, then we did a fraction. Okay, 5 minus, yeah, this is the answer that we got. Okay, now let's go to the next question. So the question number 3 tells us that we need to find the result of 3 by 4 multiplied by 1 by 2. So 3 by 4 into 1 by 2. Okay, so 3 by 4 into 1 by 2, what we can do here is we directly multiply the denominators, that is 4 into 2, and directly multiply the numerators, 3 into 1, that is equal to 3 by 8. Okay, so what we can see here is we got the answer 3 by 8. This can't be further simplified. Okay, so this is the answer. So here we multiplied the numerators and the denominators. Okay, and we got the answer this. In decimal, what it will become is 8. Okay, 3.0. So 8 into 3 equal to 24. So what it will become is 6. Okay, 0. Then it becomes 8 into 7. Okay, that is 56. Then 4. Then another 0. So that will become 5. Okay, so and here we have 0. So in decimal it will be 3.0.37 and 5. Okay, this is not asked, but I just evaluated it. Okay, so what problem number 4 tells us is we need to divide 4 by 5 by 1 by 3. So what we have here is 4 by 5 and we need to divide it by 1 by 3. So we can write it something like this. Okay, 4 by 5, 1 by 3. So this is nothing but equal to 4 by 5 into 3 by 1. Okay, we know how to solve this. We multiply the denominators and numerators. So we multiply 4 by 3 to get the final numerator, and we multiply 5 by 1 to get the final denominator, that is 12 by 5. Okay, so this is the answer. Let's see. So what we did was, yeah, reciprocal of 1 by 3 is equal to 3 by 1. Okay, we took the reciprocal here and multiplied it, and then what we got was 12 by 5. We got 12 by 5. Okay, so let's see problem number 5. So what is the result of 0.5 plus 1 by 2? Okay, so what we need to do is here 0.5 plus 1 by 2. We can write the decimal form of 1 by 2, that is 0.5 plus decimal form of 1 by 2 is nothing but 0.5, that is equal to 1.0. So this is decimal form 1 by 2. Okay, so 0.5 plus 0.5 is equal to 1.0. So let's see the answer. So in step 1, what we did was convert 0.5 to fraction with a denominator of 2. Also, yeah, we can do this. So we can also do this, like we have 0.5 plus 1 by 2. This is answer solution 1. This is solution 2. Okay, we can solve it by 2 methods. So we can do this, that is convert the fraction into decimal. This is what convert fraction to decimal, and in this case what we did was convert decimal into fraction. Okay, so what we will do here is we convert this decimal into fraction. Okay, so 0.5 is nothing but 5 by 10 plus 1 by 2. So what we can further write here is we can find out the LCM of 10 and 2. Okay, so for 2 its multiple series will be 2, 4, 6, 8, 10, 12 and so on. And for 10 what it will be is 10, 20, 30 and so on. So we can find out the common here, that is 10, and also 10 is the lowest here. So that is why the LCM of 10 and 2 are 10. Okay, so we need to convert 1 by 2 to a fraction that have denominator 10. So 5 by 10 plus 2 into 5, and then we have 1 here. So in order to equalize this fraction to this, what we need to do is multiply by 5. Okay, so what we have now is 5 plus 5 by 10, that is equal to 10 by 10 is equal to 1.0 or is equal to 1. Okay, so what we have here is the same answer. Okay, the answer are same, just we did two methods here. Okay, solution 1, solution 2. This is using method 1, method 2. Okay, there are two approaches to solve this question. So let's jump into the conclusion here. So we add it down here. Okay, let's see the problem number 6. What it tells us to evaluate is we need to find 0.9 minus 2 by 5. So 0.9 minus 2 by 5. Okay, so let's solve it first by method 1. Okay, that is converting fraction into decimal. Okay, so here we have only one fraction, that is 2 by 5. So 2 by 5 to fraction. How can we solve it? So 2.05, right? We got a decimal here. So 4, 2.0 and this is 0. Okay, so 0.4 is the decimal form of 2 by 5. So 0.9 minus 2 by 5 is actually equal to 0.9 minus 0.4, that is 0.5 answer. Okay, so by method 2, so what method 2 tells us is convert the decimal to fraction. Okay, so what we need to do is we have a decimal down here. Okay, so 0.9 minus 2 by 5, this is equal to 0.9 can be written as in fractional form 9 by 10, right? So 9 by 10 minus 2 by 5. So we need to find the LCM of 10 and 5. So the number series tells us that 5, 10, 15, 20. This is the multiple series of 5. And what is the multiple series of 10? This is 10, 20, 30 and so on. So the lowest common is something like 10. Okay, so we need to convert this fraction to a fraction that have denominator as 10. Okay, so what we need to do is 9 by 10 minus, we need to multiply by 2 with 5. Okay, 5 into 2 and then multiply 2 with 2. Okay, so this is now 10 and 9 minus 4, that is equal to 5 by 10. So this is nothing but 1 by 2, that is equal to 0.5. Okay, this can also be directly written as this. So this is the answer, and you can also see that again these two are nothing but same, because just the method changed. It shouldn't change the answer, right, if the method is correct. So this is how we found out the answer. So we can see down here, we have converted the fraction to we have converted the decimal to fraction and then solved it. Okay, what we have got down here is 0.5. This is the answer. So let's jump into problem number 7. So what is the result of 0.4 into 1 by 2? So we need to find that 0.4 into 1 by 2. So 0.4 can also be written as 4 by 10. So 4 by 10 into 1 by 2 is equal to, what we need to do is multiply the denominators, that is 10 into 2, and then multiply the numerators, that is 4 into 1, that is equal to 4 by 20. So this is the answer, that is actually equal to, we can write it as in simplified form 2 by 10. This is equal to 0.2. This is the answer. Okay, so let's see it. Yeah, this is how we have got answer 0.2. Okay, so what problem 8 tells us is to simplify 18 by 24. Okay, so in order to simplify this 18 by 24, okay, let's see the prime factorization of 18, that is 3 into 2 power 3, 3 into 3 into 2, and for 24 it is like 4 into 6, that is equal to 3 into 3 into 2 by 4 into 3 into 2, that is actually equal to 2 into 3 square by 3 into 2 cube. This is the prime factorization form. Prime factorization. Okay, so here we can see that we have simplified it to 2 into 3 power 2 and 3 into 2 power 3. Okay, so what we can do is we can cancel this 2 power 1 and minus 1 to the power of 2. Okay, so that is 3 power 2 in the numerator, and in the denominator what it becomes is 3, sorry, yeah, 2 power 3 minus 1, that is equal to 3 power 2 by 3 into 2 power 2. Okay, we have another one here, so this will further be simplified to 3 by 2 power 2, that is equal to 3 by 4. So this must be the answer. So what we did was find the greatest common divisor, GCD of 18 and 24. So the GCD of 18 and 24 is 6. Okay, then we divided both the numerator and denominator by the GCD. Okay, this is another method. We did it by method 1, it is by prime factorization. So what method 2 tells us is we can find it by GCD. Okay, so what we need to do is we have two numbers here, one is numerator, one is denominator. So it is 18 and 24, this is okay. So what we need to do is find the GCD, that is greatest common divisors. So we already know how to find the divisors. For 18 it is 1, 3, 2, 6 and 9 and 18 itself. Okay, for 24 it is 1, 2, 3, 4, 6 and 12 and 24 itself. So if we need to find the greatest among these, okay, greatest common divisor, so what are the common ones? This is the common one. Okay, can you see any other common one? Okay, 3 and 2 and 1, we can see this. Okay, but what is the greatest? The greatest is 6. Okay, that is why GCD of 18 and 24 is actually equal to 6. Okay, so what we will do is we will divide 18 by 6 and 24 by 6. So what it will give us is 3 in the numerator, and in the denominator what we will get is 4. So you can see that we are getting the same answer. just using two different methods. Okay, we solved it by two different methods. So the first method was by prime factorization, and the second method was by GCD. Okay, and we are getting the same answer. Okay, so here you can see the answer. So let's see problem number 9. So it tells us to simplify the fraction 22 by 33. Okay, so in order to simplify it, what we need to do is 1 by method 1 prime factorization, and method 2 GCD. Let's solve it first by GCD method. Okay, so for GCD of 22, 33, what it will be for, let's see the divisors of 22, 1, 11, 22. These are the only three, and 1, 11, and 33. So the greatest common divisor is 11 here. Okay, because 1 is also there, but it is the lowest, and 11 is the greatest. So that is why this is equal to actually 11. So what we will do is we will divide 22 by 11 and divide 33 by 11 in the denominator, just to equalize things. So what it will give us is 2 by 3. So this must be the answer. Okay, so let's see it by prime factorization. By prime factorization, what we can see, the 22 is equal to nothing but 1 into 11 into 2, and by prime factorization of 33, what we can see is 1 into 11 into 3. Okay, so we can write this as 1 into 11 into 2 and 1 into 11 into 3, and by cancelling these, what we are left with is 2 by 3. So this is also the answer, and these two answers are actually same. Okay, just different methods. On method 1, method 2. This is by prime factorization, this is by GCD. Okay, so we found out the GCD. First we found out the divisors, then we found out what are common among them, and then we found out what is the greatest among them. Okay, so the GCD of 22 and 33 is 11. So then we divided it, and we found out that 2 by 3 is the answer. So let's solve problem number 10. That told us to simplify 35 by 42. By prime factorization, what we can see that this is nothing but 7 into 5, and this is nothing but 7 into 3 into 2. 7 into 6 is equal to 42. Okay, so what we can cancel out here is 5 by 3 into 2, that is equal to 5 by 6. So 5 by 6 must be the answer. So let's see it by the GCD method. Let's find out the divisors of 35. Divisors of 35 is equal to 1, 7, 5, 35. Okay, and divisors of 42 are 1, 2, 3, 6, okay, 7, and 42, 21. Okay, so, and okay, okay, and 42. Yeah, I have written it. Okay, so these are the divisors of 35, and these are the divisors of 42. So we need to find the common ones. This is common, this is common, this is common. Okay, we have 3, no, not 3. Okay, so what is the greatest common divisor? It is 7, right? So we need to divide 35 by 7 and divide 42 by 7. What it will give us is 5 by 6. So this must be the answer. And we saw that by both the methods, by method 1 and by method 2, we found out the same answer. So here you can see it. This should is 7, and we got the answer. Let's see the next problem, that is problem number 11. What we need to do here is we need to compare 2 by 9 and 0.25. Okay, So in order to compare, what we need to do is we need to convert this fraction to decimal. Okay, we can do the opposite also, but let's see by first converting the fraction to decimal. That is, let's convert 2 by 9 to decimal. So 9 is down here and 2 is down there. Okay, so 1 to 2 is equal to 1 8 minus, so this is equal to 2 0 0 into 2. Okay, again 2 and then again one of the 0. So what we can see here is we can see a pattern down here. Okay, 0.222222. Okay, so 2 by 9 is nothing, 0.222 and so on. That is actually can be written as 0.2 bar. Okay, and the other decimal is 0.25. So 0.25 is greater than 0.23. That is greater than 0.2222 and so on. So we can see here is that 0.25 is actually greater than 0.2 bar. Okay, that is equal to 2 by 9. So by comparing, what we found out was this one is greater than 2 by 9 answer. Okay, so let's see here that we found out the decimal, that is 0.2 bar, and we compared the two values, this and this, and what we found out was 2 by 9 is actually less than 8, or we can say that 0.25 is greater than 2 by 9. Okay, answer. So again we can compare 5 by 9 and 0.555. So 5 by 9, how we can do it? 5 9, okay, 0.0 and 0 point. So 9 into 5 is equal to 45. So this is 5 and again 0. We can get a 0 down here, and then we can again write 5 and minus 5 is 5. So we can again see a same repeating sense here. So 5 by 9 is actually equivalent to 0.555 and so on. Okay, that can also be written as 0.5 bar. Okay, 0.5 bar. So we need to compare 0.555 and 0.555. So basically these two are same. Okay, this is repeating decimal. Okay, let's see here. Okay, yes, there are only finite terms here. Okay, but here it is repeating and non-terminating. So since this is non-terminating, 0.555 is actually less than 0.5551, that is actually less than 0.5555, and that is actually less than 0.5555 and so on, that is equal to 0.5 bar. So we can say that 0.555 is actually less than 0.5 bar, that is equal to actually 5 by 9 here. Okay, so we can say that this is greater than 0.555 answer. Okay, this is repeating decimal. Okay, we can write it by 0.5 bar and we got it here. This is greater than 5 by 9 is greater than 0.555. Okay, so we can compare 4 by 7 and 0.571 like that. So let's convert 4 by 7 into decimal, that is 7 4.0 and 7 into 5, sorry, yeah, So 35, and we have got 5, and then again another 0, we can put it down here. So 7 into 7 is equal to 49, and then we have 1, then we can put another 0 here and make it down here. Okay, into 1, so it is 7, so minus, so 3, we can put another 0 here and take it down here, and we can find out that 7 into 4 is equal to 28, right? So this is 2, we can again, so here what we have is 0.5714. So this is actually equivalent to 4 by 7 is actually equivalent to 0.5714, and the number we have down here is actually 0.571. Okay, and we can also write it as this. So since 4 is greater than 0, 4 is greater than 0 clearly, right? So that is why this inequality holds here. Okay, so the answer is something like this. This is greater than 0.571 answer. Okay, I did this and we found out that. Okay, this is the answer. So let's conclude this lecture here. Okay, thank you.